Hello ladies, gents, and everyones. It is Thursday, July 15th, and we're here to talk about this week's space and astronomy news. First up, you may have heard that billionaire Richard Branson just made it to space this past weekend, becoming the second billionaire to do so, and the first to do so from basically his own company's vehicle. Now, this timing of this flight was sort of suspiciously announced after Jeff Bezos announced the timing of his upcoming Blue Origin flight, where he is going to space, but I don't think it takes anything away from either flight. Now, the Virgin Galactic flight was successful, reaching an altitude of about 53 miles, which is just high enough to reach what NASA considers earning one's astronaut wings, which is anything above 50 miles, although it falls short of the Kármán line, which is sometimes considered the boundary with space. The problem here is that the boundary between what's considered atmosphere and what's considered space is very gradual, and so there's really hard to say exactly now you're in the atmosphere, now you're in space. So some may claim that Branson didn't make it to space. He certainly thinks he did, and if I were him, I would too, so. Branson wasn't the only one on board. This was actually the first fully crewed Virgin Galactic flight, and they got to experience several moments of weightlessness at apogee of the flight, and they landed successfully. So one thing about Virgin Galactic that you may have noticed if you watched any coverage of this is that their launch vehicle is a little different than the standard kind of put it on a launch pad and bang that you might be used to. So they actually use a plane to lift the space vessel up into the atmosphere about, I don't know, 10 miles, a little less than 10 miles. And then from there it releases the spaceship, which then ignites its own rockets to boost itself up into space. Then that space vessel can actually land itself with its kind of retractable wings back at the spaceport that it originally launched from. So that's what they did for this flight. The space plane that took them up was the VMS Eve, and the spaceship that took them to space was the VSS Unity. So speaking of those billionaire space flights, next up it is Jeff Bezos' turn with Blue Origin. So their first crewed New Shepard mission is planned for July 20th, which is next week. And as of today, the full crew has now been announced. So it's going to be Jeff Bezos and his brother Mark, along with Wally Funk, an 83-year-old woman who trained to be an astronaut as part of the unofficial Mercury 13 program back in the 60s. And now the last seat was supposed to go to the anonymous winner of the auction that they had for the seat that went for $28 million. However, they said that the winner of the auction actually wanted to reschedule. They couldn't make this July 20th flight, and so instead the 4th seat is going to be filled by 18-year-old Oliver Damon. Now, Blue Origin called Damon their first paying customer, but did not, to my knowledge, reveal what he actually paid for this seat, and the winner of that auction is still anonymous. Now, the proceeds from the auction were supposed to go to Blue Origin's nonprofit Club for the Future, and they did, and Club for the Future just announced this week that they were making $1 million donations to 19 different space organizations out of that funding, including the Planetary Society, of which I have been a member for many years. Now, this New Shepard mission is actually going to go a little bit higher. It's going to reach above 62 miles, so it is going to pass that Kármán line into space. And they're going to experience about 10 minutes of weightlessness during their flight. And if successful, this flight will actually contain both the oldest and the youngest astronauts ever to go to space, which is pretty cool. So definitely best of luck to the New Shepard 16 mission, and hopefully everything goes off well for them next week. The poor Hubble Space Telescope has now been down for over a month. All of the troubleshooting that the team has done was not able to bring the telescope back online. However, they think they have finally actually pinpointed the cause of this failure. And in fact, it's something called the power control unit. So this is something that's supposed to regulate the voltage going to the payload computer, and it has a secondary kind of protective circuit. And if that protective circuit notices that the voltage being output by the power control unit isn't what it's supposed to be, then it puts the telescope in safe mode, is what happened. And so either something is wrong and the voltage getting put out of the power control unit is not actually correct, or there's something wrong with the protection circuit saying that it's incorrect even when it's not. In any case, the fix now is going to be to switch to a different power control unit, which is part of a different backup science and instrument data handling and control computer. So NASA is planning to do that starting today. It will take them a few days to make the switch and then do all the testing that's required, and then hopefully bring the Hubble back online for science operations. Really hoping for that. Speaking of Hubble, okay, actually this is a totally different Hubble, it just also happens to be named after Edwin Hubble. This is the Hubble constant. So the Hubble constant is a value that sets kind of how fast distant galaxies are receding from us due to the expansion of the universe. This recessional velocity due to distance was first characterized by Edwin Hubble and gets the name Hubble's law, and so this is why we call this the Hubble constant. Now, scientists have been trying to measure the Hubble constant for about a century now, and at first they weren't very good at it, and they could only do it to within a factor of about 2 or so. But over the years, the methods for measuring it have gotten a lot better, and so the error bars on these measurements are getting smaller and smaller. In fact, they've gotten so small now that the error bars between the two different methods, the main methods that we have, don't match. And this leads to something that's called the Hubble tension. That is to say, a tension between what the two different methods of measuring the Hubble constant tell us that it is. So one method is the kind of local or late universe method, and we basically directly do exactly what Edwin Hubble was doing. We look at distant galaxies, we measure their recessional velocity, and we measure their distance from us. But the key thing here is that measuring the distance is really hard. So most of this relies on certain distance indicators called Cepheid variable stars and type 1a supernovae. The other method is a little bit more indirect, and it deals with the early universe. See, Hubble's law deals with the expansion of the universe, and that expansion has kind of left its fingerprints on the universe, including in the very earliest light that we can see from the cosmic microwave background. So based on our cosmological model of the universe, we can measure the cosmic microwave background and infer a Hubble constant. And these two methods don't agree, and the error bars are small enough that that disagreement is significant. Now, basically speaking, there's kind of two obvious solutions to the Hubble tension. One is that the error bars are being underestimated by either one or both of these methods, and that in fact they do agree, they're just not being measured precisely enough. And the other is that there's some sort of new physics that we don't understand. So something that needs to go into our models to account for this difference between the apparent local universe measurements and what we get from the kind of wider universe, early universe measurement. So now there is a new independent distance method that's been used to measure the value of the Hubble constant. So this is a local universe method, but it's independent because it's using a different way of measuring these distances. And interestingly enough, this new local universe measurement actually agrees with the indirect early universe measurements, indicating that perhaps there is no tension at all, and that it's just been an underestimate of the errors and basically missing some sort of systematic error or uncertainty that's associated with these measurement methods that we've been using. Solving this question once and for all would have really big implications for our understanding of cosmology and our universe and how to measure distances, so this is really exciting news, and this is super awesome to see that possibly the Hubble tension is no more. So every year, the Royal Museum Greenwich in England hosts a Astronomy Photographer of the Year contest. And this year's contest received over 4,500 entries from 75 different countries. Now, the winner won't be announced until September, but they just released the shortlist and all of the images from the shortlist. And you guys, they are amazing. You have to go check them out. I think this is so fantastic, and so I wanted to share with you so you can get a chance to go see some of these amazing pictures. And I think this is really important. Astrophotography is super difficult. I am so impressed with these photos that people are doing, and I think it's super important not only because they're beautiful, but also because it excites us and it evokes the kind of wonder and awe of the cosmos and hopefully inspires some of us to get into science and astronomy, which is always what I like to see. So really cool, so definitely the link that below, check out all of those amazing photos, and stay tuned for who the winner is going to be. Well, that's it for me this week. Thank you so much for watching, and I will see you again next week. Have a good one. Bye.